Section 6.6 is more graphing inverses. We did this in the last section as well. All right. So the directions say find the inverse of the function y equals cotangent x, then graph both of the functions. All right. Well, we know to find the inverse of a function, we switch the x's and the y's, and then we solve for y again, get y by itself. So switch the x's and the y's, we get x equals capital cotangent of y. All right. So in order to solve for y again, we need to get rid of this cotangent, and we know to get rid of something in algebra, we need to undo it, or we need to do the inverse of it, right? The inverse of um, 1/2 is 2 over 1, right? The inverse. Okay, so we actually have commands for that in Trig, and we've learned a couple of those. But if we take the cotangent inverse of each side, these two undo each other. And in algebra, as long as we do it to one side and we do it to the other, we're safe. So now we have y equals the cotangent inverse of x. And they're saying, oh boy, we got to try to graph that because that's what the directions say. Well, we've done some of that. It would first off, you'd start off graphing the cotangent graph. And then in order to graph cotangent inverse of x, you just flip the x's and the y's. To make this video go a little quicker so it's not so long, I'm going to show you here on a graphing calculator what it looks like. This is a graph here of tangent, all right? Each one of these is 90 degrees, so from negative 90 to 90, there's asymptotes, and in between there's what I call the disco dancer graphs, okay? So starting there, we go from tangent, cotangent, we just is a reciprocal, it's flipped, all right? So let's go to the cotangent graph, okay? Show the cotangent. Let's get rid of the tangent graph. See how? Sorry. Let's show them both. See how it's flipped of each other. All right. So anywhere where tangent had blue is tangent. Anywhere where tangent was undefined, cotangent is now defined is now 0. All right. Anywhere where tangent was undefined, that was 1 all over 0. Well, now it's 0 all over 1 because it's the reciprocal. Okay, and then anywhere where tangent was 0, it's now an asymptote for cotangent. So that's what the red is the cotangent graph. So let's get rid of that. Just show the cotangent graph. Okay, so there we are right there. All right, and to find the inverse of this now, the inverse is we just flop the x and the y's. All right, each hash mark here is 90 degrees. In radians, it's pi over 2. That's why you're seeing 1.57. Okay, so you're seeing here is the ordered pair 0, 90 degrees 0. So if we flip that around, it would be 0, 90 degrees. So it's going to be up in here. All right, so let me go ahead and show you that graph, the cotangent inverse graph, and the other one side by side. Okay, so here was 90 degrees 0. And now when we flip the ordered pair, we switch the x's and y's, it became 0, 90 degrees up like that. Notice just like in the other graphs, this has a specific principal values, which means it has a specific area and only goes once. All right, and that's from 180 degrees down to 0. Each of these tick marks are 90 degrees. So that's the graph of the cotangent inverse, and we can do that by finding its original graph, okay, and flipping the x and the y's. And I just wanted to show you on a graphing calculator to make it easier for you and make this video shorter. All right, so moving forward, we have write the equation of the inverse of the function and graph both the function and its inverse. All right, so let's write the equation of the inverse. A lot of you guys like this part because it's algebra, it's easy, it's not graphing. I think that's why you like it the most. But here we go. To find the inverse, we switch the x's and the y's. All right, so this becomes x equals pi over 2 plus sine inverse of y. Okay, so we need to solve for y again. Let's get y by itself. So subtract pi over 2. So I have x minus pi over 2 equals sine inverse of y. Well, to undo sine inverse, we're going to take the sine of it, right? So the sine, and so they cancel out. And we're going to take the sine of both sides, like so. So now we have y equals the sine with a capital S there. Why does that matter? Because it matters with our principal values, because we started out with a capital S. Sine of x minus pi over 2. All right, now they're asking us to graph those guys. All right, well, I know that we can graph this. I know we can graph that. Okay, we learned that the principal values of capital sine, all right, we learned that principal values was where the original function and its inverse are both functions, all right? So we learned that the sine has principal values from negative 90 to 90. And that's the only ones we're going to use when we graph both of these guys, okay? So I know we know how to graph this guy, all right? If you think about it, um, our period 360 over k, our k is 1 right here. So we have a period of 360. Our phase shift, negative c all over k. So this pi over 2 is 90 degrees. So it would be to the right, 90 degrees would be our phase shift, okay? And we're only using the values from negative 90 to 90. So everything, my original sine graph would look like this. But now everything's been shifted to the right. So this actually has to come here. This actually has to come here. And then it would come right here is the graphs that the ones that we want because everything was shifted now. Okay. So that's that function there. All right. And if we were graphing this guy right here, where they want us to graph the original, okay, we know that the sine inverse graph, the original sine inverse graph goes like this. It would go like this. Okay, like that. Okay, but we know that it's now because this pi over 2 is outside of it, it means that everything's shifted up 90 degrees. So I'm going to make another hash mark. Remember, each of my hash marks are 90 degrees. So everything's shifted up 90 degrees. And again, we're only going from negative 90 to 90. So we're only going from here to here. So everything moves up. Originally, this thing would keep going down. It keeps that pattern. Remember how it keeps a pattern? It goes like this and so forth. So we're going to shift everything up 90 degrees. So this thing's going to get shifted up to here. This guy's got to get shifted up 90 degrees to here. And it looks like it'd be another 0 that would get shifted up to here. So our graph of our inverse is just like that. Okay, and that makes sense what we have here. We could take this guy and we could also flip the x's and the y's. All right, I hope that helps in graphing, and you're going to learn by doing it, and there'll be more examples on your assignment. So I have 2 more questions for you here, 2 more examples on this video. It says determine if cosine inverse of cosine of x equals x for all values of x. If false, give a counterexample. So what's that is saying is for any angle that we can pick, all right, does the cosine with that capital C, all right, will it equal out on both sides of the equation? So we know that the cosine equation goes from 0 and 180 degrees, all right? That's what we're dealing with when we add up capital C. Pick any cosine, any x that we want, because we can take the cosine of any angle. So let's say 30 degrees. So the cosine of 30 degrees, capital cosine inverse of that. And will that equal 30 degrees? Yes, no, maybe. I have no idea. Let's check it out. All right, so cosine of 30 degrees, to figure that out, let's draw my 30-degree angle, make my special right triangle. 1, 2, square root of 3. All right, the cosine of 30 is square root of 3 over 2. And then is the capital cosine inverse of that 30 degrees? Well, yeah, it is. All right. The cosine inverse is square root of 3 over 2. This is saying what angle has a trig ratio of square root of 3 over 2? Well, positive square root of 3 over 2. Okay. So fair enough. We picked one there. What about 120? Cosine inverse of cosine of x, does that equal, let's say 120, my bad, 120. Okay, so 120. Now let's draw our angle, 120. Here's our angle, 120. We use its reference angle 60 to tell what its trig ratio is. So its reference angle is 60. This means that this would be square root of 3. This would be negative 1. This would be 2, using my special right triangles. The cosine of 120 is negative 1 half. All right. And then the capital cosine inverse of negative 1 half. Does that equal 120? Yeah, it does. All right. What angle has a cosine of negative 1 half? Cosine of negative 1 half. Yeah, yep, this angle has a cosine negative 1 half. It's adjacent is negative. Hypotenuse is 1 half. But when we don't have this capital letter in here, anything's free game. So let's pick something outside of that 180 degrees. What about, I don't know, 240? Cosine inverse of the cosine of 240, will that equal 240? Okay, well, we can figure out the cosine of 240. The angle 240 goes way over here, all right? And it's 60 degrees past 180, so our reference angle is 60 degrees. That means this is negative square root of 3, this is negative 1, and this is 2. The cosine of 240 is negative 1 half. So capital cosine inverse of negative 1 half, does that equal 240 is the question. Well, our answer is going to be no, because anytime we're dealing with this, we're dealing with the principal values, we're saying these values have to be between 0 and 180. All right? So my cosine inverse of negative 1 half, I get it. I can get a cosine inverse of negative 1 half, but it's going to be in this quadrant over here. It's going to be this angle, 120, with a reference angle of 60. And this would be the square root of 3. This would be 2. This would be negative 1 half. I can get a cosine of negative 1 half within this range right here, but that's not going to equal 240. When I do the capital cosine of negative 1 half, that is actually 120 degrees. It's this right here. That does not equal 240. So that does not work for all values of x. All right. So there's my counterexample. That's where it doesn't work. So in order to solve those, you just pick angles that you can think of. All right, and see if it's true. I think you probably learned something in the second one. Determinative sine inverse of sine of x equals x for all values of x. Give a counterexample if possible. Well, we know that the capital sine inverse, that goes from negative 90 to 90. Negative 90 is the same thing as 270, right? Just so we're on the same page. All right, so let's pick a number not in here, and if it works, then it might work for all numbers. If it doesn't, then we have our counterexample. So let's pick like, oh, I don't know, 150 degrees. Okay, so 150 degrees has a reference angle of 30. And my special right triangle say this is 1. This would be negative square root of 3. And this would be 2 using my 30, 60, 90 triangle. All right, so I'm wondering if the sine inverse of sine of x equals x, and we're making that x be 150 degrees. So let's go ahead and put that in there. Okay, instead of x. All right, so the sine of 150 degrees, the sine of 150 degrees would be 1 half. Does my capital sine inverse of 1 half, does that equal 150? Well, we know that the capital sine only goes from negative 90 to 90. It can only be in these two quadrants right here. And we can get a sine ratio of 1 half. It's just not going to be the one that we're looking for in 150. If I have 30 degrees as my reference angle here, I know of my special right triangles, this has to be 1. This has to be 2, and this has to be the square root of 3. I can get a sine ratio of 1 half. However, it's not 150 degrees. It's actually 30 degrees. So 30 degrees does not equal 150. So therefore, there's our counterexample in that case. You'll have problems like that. Sometimes they'll all be true. Sometimes you'll find a false one right away. Make sure you just pick values for x and try to find a counterexample. Hope this helps. We'll see you in class.